The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. Just share my screen here. Okay, welcome everybody to this first ANZ community virtual meetup for structural and fabrication. I welcome you all. My name is Stefan Gumpert. I'm the host today, and we have three interesting people to have a chat today. We've got Dan, Ovi, and Gernot, who will be talking about three different topics, hopefully all interesting for everybody who's on the call. So Dan's going to be going first, talking about precast concrete. We've then got Ovi, who's going to be covering cast in place concrete or cast in situ, followed by Gernot, who will be covering the steel side. So one thing that I would like to, talk about, there is a Q&A or a chat panel or a question panel where you can ask questions. Please ask as many questions as you like in the question panel itself. We may not answer all these questions before the end of the session, but if you ask the question, we will get the questions answered and the answer, sent back out to you. All right, let's move on. So now what I'll do, I'll hand over to Dan, and Dan can start showing his stuff. Give me a second here. Okay, Dan, I believe you can share your screen. Yep. There we go.
Okay, can you see my screen?
We can.
Okay, perfect. So good afternoon, everyone. It's a pleasure to be part of this event today and to meet everyone online now. My name is Dan Peticilă. I'm the product manager for precast concrete and cast-in-place concrete for Revit. I'm based in Bucharest, Romania. I've been with Autodesk for 5.5 years now. Have a structural engineering background, and I have many interesting things that I like to present to you today about precast, and only 10 minutes, so let's kick things off, and in the end we've reserved that time for some of your questions. Okay, so first of all, important to highlight the workflow. Our precast automation is dedicated to engineers and detailers, typically collaborating with highly automated precast factories. And we are delivering a rule-based automated workflow for 5 types of precast elements: solid walls, solid slabs, double walls, girder slabs, and hollow core slabs. These are automatically split, fitted with mounting parts and reinforced, and then shop drawings and chem files are automatically generated. Eventually, these chem files, as you see right now on the screen, drive the fabrication process. So the robots from those highly automated factories, and can also feed various ERP systems. And one more thing that's maybe worth stressing out is that because everyone is using the same model, you can achieve multidisciplinary coordination with MEP and architecture, of course. Also, being a Revit-based solution, we are leveraging all the advantages of this platform. One of the most important being the level of development differentiation using the concept of parts. This means that each persona that's engaged in the model can take a look at it from the desired perspective, always having the same source of truth. Basically, the engineers, the detailers, the contractors, or even the architects can look at the model the way they need. All of this just relying on the parts concept and, of course, the visibility settings that Revit offers. Okay, so now let's have a quick glance again at the workflow. So the basic steps that we are proposing for each of those elements that we support is once the rules have been set and once you are incorporating into those rules not just the design related ones, but also those coming from the fabricator. You need to split the elements into parts, into fabrication assemblies, basically. Once they are split, fabrication and mounting parts are added to it as well. Then reinforce them automatically. And further on, create the documentation. It can be in the form of shop drawings or in the form of CAM files. And the CAM files that we can create are of various formats. It can be Unitechnic 5.2, 6.0, and 7.0, as well as PXML 1.3. Now, the settings, it's something that we should cover a bit. And of course, there are many things to talk about here. I'm going to present you the main rules, basically, that can be incorporated into this settings dialog box. And if you have further questions around this, feel free to write your questions in the chat, and we will answer these either online or offline. So first, there are the segmentation rules, and basically you can split elements based on the minimum and the maximum panel size, the weight. Then you can specify which lifters or bushings to be used, the distance between them, as well as connections with the neighboring panels. It's important to say that the segmentation can also be performed manually. For example, in some cases, you want to impose a specific segmentation place due to, I don't know, architectural demands, let's say near a particular opening. So you can do that, and afterwards you can apply the automatic segmentation, which will obviously respect the manual division that has been dictated. We offer some out-of-the-box components, so families of lifters, of bushings, of connections, but you can further customize them to look into the ones that you actually use or are imposed by the fabricator. Next are the reinforcement settings. You can use either rebar sets or fabric sheets. You can define how many layers of reinforcement need to be placed in each element. You can have from 1 up to 5 layers of reinforcement. You can define the edge reinforcement, which can be done using straight bars or U-shaped bars or L-shaped bars. And further on, you need to define the settings for the shop drawings, like what dimension styles and which types of embeds should be annotated, which drawing template to be used for each type of element. These templates can also be customized. I think we've seen parts of that in the video that I showed. And of course, they can include all the types of viewports that you need, 2D or 3D, and of course, the schedules and the list of materials. One important thing to say is that you can have multiple shop drawings actually for the same assembly. Let's say that you need one for the formwork, so for the guys in the factory to check that the shutters have been placed correctly, and one just with the rebar and the embeds, because these are different fabrication stages basically, so may require different documentation. And last but not least, there are the CAM export parameters where you can customize the file name. And yeah, one other good thing to say here is that this CAM export is not just for precast assemblies. Consider using it also for rebar assemblies too. So if you need to drive machines to bend the bars, even for cast in place concrete projects, you can use this tool that's part of our precast tools. And speaking of reinforcement, I think it's also worth saying a few words about the custom fabric sheets that we are supporting for a few versions now. I think it was released in 2019.2, and the custom fabric sheets are meshes that can be defined using lots of flexibility while respecting the restrictions of the mesh welding machine that fabricators own. So you can create them like having a perfect match with what they can actually do. And you can impose here, of course, the minimum and the maximum length of each wire, the spacing between the wires, and the number of minimum welding points that each wire must have. Lots of settings really that we are covering. And now I would also like to speak to you about how you can get even more automation for precast concrete with Revit. On one hand, there are more types of precast elements for which we do not offer out-of-the-box automation, but our technology partners do. I'm thinking of columns, beams, and bed foundation, facade walls, and so on. And on the other hand, we know that even for our out-of-the-box supported elements, there are still different variations in each region or even in each factory. And that's where we are also relying on what our partners can deliver, as they have tailored solutions, and that is based on their local expertise collected from various markets. And of course, they can also build on demand even more such customized solutions. And maybe because this is like a product focused presentation, let's have a look at some recent customer stories. And I'm not gonna speak much about the benefits of using Revit and BIM in general, because probably you've heard many about these in other presentations. I'm gonna focus on showing you what these other types of elements can also be addressed using Revit. Like here, this is a wall, thermally isolated wall, and isolated from the exterior elements. This is a foundation wall. It's monolithically poured with high strength concrete for giving it structural integrity, and of course it's reinforced with steel rebar, but also with polypropylene fibers. And this is typically used for basements or wood-based superstructures. Also, it's worth showing here that in the case of Sun Siri, which is this Thai company, they blended what we are offering out of the box with some of the customization that IDET can deliver. And what that customization means, it's in this case it was especially the CAM files, so the type of information that needed to be included in the files that are used by the industrial robots. And one example is how the chamfers need to look like. In this case, you see here there is this detail on the types of chamfers that factory needed to have, and of course this information needs to come from the model. So you need to model the panels using such chamfers automatically using Revit. So what IDET did was to integrate this into the automated segmentation that can be performed. Some other types of precast elements as well. And here, yeah, this is another example from the United States, and you can see here curved panels as well, facade panels, where lots of different embeds were required. And again, yes, some more representative pictures of types of elements that Revit can support with the help of our technology partners. And of course, even more automation can be done using Dynamo. I mean, if this really fits your workflow, then you can use some of our out-of-the-box packages. For example, this one that comes from our colleague Thomas Fudala, the structural design package, allows you to add reinforcement automatically around openings. This is valuable for precast workflows, but also for custom place workflows. And it can also place grout tubes and other types of embeds automatically. The scripts that are included in that package. And of course, all of these scripts can be further customized to serve better the particular needs that you may have. Okay, and I think this was it from my side. So I would like to thank you and hand it over to Ovidiu.
Okay, so I am going to cover the cast in place concrete part, and I am going to first do an overview of the new features related to rebar modeling and detailing in Revit 2022, and then do a live demo of Revit's capabilities for rebar. Okay, so this is one of the features we developed in Revit 2022. It adds the ability to move and remove bars from rebar sets. This means that we can easily avoid clashes with other building features or other rebar by doing some local adjustments, moving or removing the bars, while preserving the rebar definition. We will see in the live demo how this works. Okay, also in Revit 2022, we have a new way to place rebar in a faster and more precise manner by clicking 2 points, like the title says. This allows the rebar to be positioned intuitively inside the concrete element and aligned to any reference that is needed. A minor yet important productivity enhancement also in Revit 2022. Now all the settings related to rebar placement are stored, are maintained within the Revit session and between the various tools, so that you don't have to always select the options like layout and other options like that. Okay, for highly congested areas with large diameter bars, we now have the ability to model the rebar using the real bar diameter. This means that you can account for the striations on the bars and basically program in a tolerance to make sure that the rebars will fit on site when installed. Okay, and for the Freeform Rebar functionality, which allows modeling any geometry of reinforcement, so 3D, however complex, we now have the option to specify a shape code for these weirdly shaped bars, and this should improve the scheduling and allow a better definition of which bars will be bent in the shop and which bars will be delivered and bent on site. Okay, and it's actually a platform feature, but it's also usable and useful for rebar. In Revit 2022, tags can now be rotated arbitrarily. Before, you could only rotate the tags vertical or horizontal. So yes, this is another improvement that helps with documentation of the drawings of the rebar. Okay, so now I am going to jump into Revit and start the live demo, which hopefully will go well, as live demos do. I've clicked the rebar command, and now I have some options to place. Expand to host is the current option that we've had so far. It takes the selected rebar shape and it expands it to fill the host as I am hovering inside of it, like you can see here. Of course, this does not offer the best results in all situations. For example, if I want to steer up at the intersection of walls, I have to do a bit of adjustment. If I place it on the other side, the same, I have to adjust. In some situations, it works well, however. For example, in the corner of the core wall here, where we have an embedded column, as I am hovering the cursor, you can see that this stirrup shape is expanding properly. So one click and I've placed it. You will also notice the cover marked as the dashed green line, and the bars expand to the cover. Now, for the example of the wall intersection, to avoid this adjustment, we now have a new placement method called by 2 points. And for the current situation, I will keep the bar parallel to the work plane, and I am placing a set at 200 millimeters. So if I go here to the intersection, you will see that I have snapping to the cover from the intersecting walls, and I can click once and then move over here. I have this snap point. I can press space bar to choose the position of the end of the bar and click to place. So it is quite straightforward to place. So just 1, 2 clicks in this parallel to work plane mode. I can place bars in, I can place the vertical bars as well. So I will choose a straight shape and let's do a fixed number 4 bars. And we have an option to place the bars vertically. So here, and let's choose a larger diameter. So when I go here and I start at the corner of the stirrup, this should adjust. Okay, let's try it again. So I can place some rebar sets here on the corners. I can remove the bars that are not required, like the ones from the vertical sets, for example, and I can mirror these to the other side. Okay. Now, if I want to also do some stirrups in the other direction, let's quickly do that. So I will select a stirrup shape, and then just place it over here. And for the other direction, I can place it again, or I can rotate and copy. So rotate 90 degrees, and that's it. Okay, so this is the placement by 2 points in this region. Let's place some more rebar in this element. The expand to host option is still useful. For example, I want to place the horizontal bars spaced at 200, and I'm going to use this section view to do that. So you can see that it snaps to the cover and it extends up till the end of the element. And I can do it similarly for the other directions. Okay, I can place the bars manually, or I can copy from side to side, if whatever is easier in a given situation. For the vertical bars, we can do again the perpendicular segment option, spaced at 200, maybe a larger diameter, and just click and place. Okay, and let's mirror to the other side. Okay, so this is one way to populate the model with reinforcement using the existing and new placement methods. For the bars that I have placed, of course, I can do I can annotate for fabrication. So for the longitudinal bars which are distributed like this, we can use the Multi-Rebar Annotation, and let's choose a vertical rotation for the tag. Okay, and I can do one here as well. For the bars in the embedded column here, we can do the Multi-Rebar Annotation as well, using a different arrangement, which could look like this. Okay, and place it in the middle, and let's do a horizontal. Okay, so something like this. We have 10 bars, rebar number 86 inside the embedded column. Okay, so I can place a couple more reinforcement. So here in the column intersection, and then I can copy this to the other side. Now I am not going to add all the reinforcement in this element, although it shouldn't take much time, and the bottom reinforcement could be mirrored to the top. But let's have a look at documentation for this, and I have here a schedule, and I am going to also a 3D view of the element, and I am going to assign all the rebar a certain partition, because that is how I filtered that schedule. So let's call this CWD3. Okay, so now this is my schedule for what I have reinforced so far, using the shape image inside the rebar shape family. We can display this in the schedule when placed on a sheet. Okay, so we have the stirrup shape with the segment lengths and the arrangement of these segment lengths, B, C, D, E. And for the other ones, similarly. So these are all shapes. This demo is based on the standard metric template, but all these shapes can be customized. To suit your needs or particular shape catalog that you are using. Okay, so now let's have a look at some reinforcement in the slab on level 3. So let's place some rebar and also talk a bit about rebar constraints. So I'm going to use the placement by 2 points, and this time I'd like to model the bottom reinforcement in this slab, and I am going to use this far cover reference because we are in the level 3, and when using this option, we place rebar with respect to the bottom face of the element as we are looking at the element, at the host. Okay, so as I am hovering inside this element, I get the cover represented and I get some snap points to the cover, even if I'm a bit far away from it. If I click, and let's change the setting. If I click, I know that I am respecting the cover and I am starting from the correct position. Okay, and I can place and adjust. I can place directly to the element. I would like to place another set roughly at an overlapping distance to the bottom one, and then let's have a look at rebar constraints. So in Revit, as you may know, rebar reacts to the changes in the host. It connects to the concrete faces and it follows those faces when they are modified or moved. Since Revit 2020.1, there is also the ability to constrain any rebar together, so one rebar to another. And where this is useful in our particular example is to maybe define the splice length. So if I take the bottom bar and I would like to override or edit its constraints, we have this edit constraints command, and we are taken into an edit mode where you can see the various segments of the bar. So this is where the set starts or ends. This is the other end, and this is where these were where the bars start and end. This is where the set starts and where the set ends. So like I said, it automatically finds constraints to the host. So this is at 143 millimeters from the side of the slab. And for the end constraint, if I want to set a splice length for this for these two sets, I can come in here and click to constrain these two. And we have here the offset, which we can input manually. So for example, if I just input from the keyboard without clicking 800 millimeters, these are now overlapping by 800 millimeters. So if I press finish or enter, we will notice that when adjusting one of the sets, the other one follows. This is because when connecting the ends, the two-way constraint is automatically enabled. This is the two-way constraint, which we can do for the other segments. So if I want these sets to have the same start or be connected at the start without clashing, I can enable this two-way constraint, and for the other side as well. So now that I have done that, we can notice that dragging either of the set moves the other one as well, which of course may come in handy for modifications and for maintaining the relationships, and of course copying to another zone. So for example, if I want to reinforce this other floor area right here, I can just copy both of them together and then adjust to get the bars in position. So this is modeling. If we also want to do annotation, we can use the same multi-rebar annotation, and we can display only one or however many bars we want, because of course in a floor reinforcement we don't show all the rebar like this. So we have some quick commands here to choose the presentation. So showing just the middle bar, showing the middle bar on the bottom, or choosing which one to show if they are not, if it's not clear which one is showing. Actually, I have to deselect the other one to remove it. Okay, so these sets look like this, and if I add an annotation to it, it will look like this. Okay. Okay, so this is the bottom reinforcement. So for the 2-point placement, I mentioned that you have the flexibility to align to any reference, to refer to various references in your project, like annotation lines or reference planes or things like that. So if I want to place the reinforcement on top of the column, for example, of a certain length, I can do that. If it's snapping, it's snapping precisely. If it's not snapping to an extension, I can choose the length of the bars and the length of the set by the snapping options that I have set in Revit. Okay, if I have other references in my project, I can, by the way, this is the top reinforcement, I can snap to those in extension and place my set. If we want to align to an inclined edge like this, let's say I want to place the top reinforcement on this side of the floor. This little tooltip, which you may have noticed that is following my cursor, is showing us some options that are available. So as I am hovering over this reference, I can press up arrow and then click. Let's do it again. Okay, to align my placement to that edge. If I want it in the other direction, so 90 degrees, I can press the brackets in the tooltip or hover here and press the other arrangement. So brackets to place, and you will see the temporary dimensions which allow me to specify the length. I'm just going to go past this column, so 11 meters and the length of 3.3 meters maybe. So one click and I have placed this set aligned in this direction. What would happen in a floor if I try to place this using the expand to host method? Well, it would require some adjustment. So I could come in here and it would not be as effective, let's say. So I would have to find a suitable position and then adjust. By the way, the adjustment can be done also manually, like this, less precisely than editing the bar constraints. So edit constraints, and we are referring to this side of the element, and we are inputting a distance. Minus is towards the inside, minus 3,300. Okay. Okay. So as part of the new features for Revit 2022, I mentioned the ability to move rebar in a set. Let's quickly switch to a simple example of a beam reinforcement with an opening for some MEP pipes or something like that. One way for me to make a quick adjustment to this is to, when hovering over the set, I get an indication of how to select the individual bar. So tab, select, and then I can use the move command, or I can edit the temporary dimension with respect to something, so maybe 50 millimeters here. I can even remove the bar if I don't have a way to move it and still keep the spacing to the other bars. You also may have noticed that the dimension that was on the stirrups in this beam has adjusted. This always dimensions the let's call it the real situation. So this bar moved and the dimension is showing a larger spacing here between the bars. Coming back to the floor plan, this new ability to move the bars also works on other types of reinforcement in Revit, one of which being the structural path reinforcement, which is an array of bars defined by a path that you sketch and that can have multiple segments. In my example, it only has one segment, but if I select this path reinforcement, I have an edit bars button and I am taken into an edit mode where everything else is grayed out, everything but the bars in my path reinforcement. And here I can do multiple selection, move these out of the way, or if the opening is larger, cutting of the floor on the edge, I can click to remove the bars altogether and have some other reinforcement arrangement locally added. Okay, and finish to accept the change. Now, in my project, if I've made such changes and I would like to be aware of those changes, I can set up a filter to, and I don't have one set up right now. Yes, I do. Okay, so I can set up a filter to add the color to the rebar sets that were modified. Modified means that a bar was moved or removed from the sets. Okay, so this is now marked as red because it has some modifications inside the set. Okay, so we have talked about moving and removing bars, placement, the two placement methods, expanding to host and by 2 points. And we have talked about constraints. Constraints is something very powerful in Revit, which can be very valuable when doing modifications, when needing to do modifications to the model. And I have an example of a wall reinforcement that looks like this. So I've also annotated the reinforcement inside this wall, and this wall has a door opening inside of it. Now, these bars are constrained together, like I showed previously. So let's see what happens when we go in and move the opening. So I will activate this view, I will select the opening, and if I just move it manually, we can see that everything updates in all views and all the reinforcement with all the annotations and rebar schedule. Okay, so for such modifications, it is quite straightforward to manage these kinds of changes, which often appear in projects for various reasons, and keep the model coordinated and up to date, and with less effort. Okay, so moving the wall updates everything, all the reinforcement inside of it, and the schedule. Okay, and I guess I am close to the time that I have for this presentation. I'd like to show one more example, because moving bars in a set is not only moving, it's any kind of movement, so including rotations. For rebar in Revit, we have the option to rotate the hooks at any orientation. So for all the bars in the set, I could rotate hooks. If I want to rotate at 45 degrees, I'm rotating all the hooks. Okay, so back to 0. But if we look at top section, if let's say we would want to fan out these bars for anchoring inside an element, the floor or the foundation, whatever, we can come in here and select 1 or 2 sets, do edit bars, and then rotate these individually, for example, by 45 degrees. Why didn't it rotate? "45. I don't know why it's not rotating. I did say that it's a live demo and something may go wrong. And I don't know why it's doing that. But anyway, if I don't manage to rotate, you can. I don't know why it's not rotating. That's strange. It's not rotating because I have copy on. Yes, okay, so copy off 45 degrees. That's why it was not rotating. Okay, let's do the other ones as well because it looks better. And this one. Okay, and finish and back to the 3D view. We can have these bars fan out like this. They are still shape 25 with this length for the hook and for the main segment, but they can be fanned out like that to not clash. Okay, so I think this concludes the demo on cast in place concrete. If you have any questions Stefan mentioned, please post them to the Q&A area, and we will answer within this meeting or afterwards. Also, if you have any suggestions or needs for your rebar modeling workflows, you can post those as well. So thank you. And I'm going to hand it over to Gernot.
Okay, thanks for video. Can you hear me? Can you see my screen?
Yes.
Very good. Yes, hello from my side as well. My name is Gernot Jeromin. I'm the structural steel product manager here at Autodesk. So therefore, let's talk about steel. I would like to start with something we have done and added to Revit 2022 first. In Revit 2021, you are able to create steel connections, save them as connection types in some kind of library, and by using Dynamo, you can define how those can be applied to your model automatically. So we are talking about connection automation. In Revit 2022, you can define ranges of clippability within the connections. That means you have additional tabs within your connections where you can define in which ranges a connection can be applied. So there could be multiple definitions for each member, where you can say, for example, for which shape size, which material grade, which end member forces this connection type might work. When running Dynamo, those connections will only be placed as long as they fit into those ranges. And this makes it much easier to define your rules for the automation, and you can be more precise. It's very cool stuff. And just as a remark, you could, in example, create your basic model in Advanced Steel, import that into Revit, run the automation to apply your connections, and send them back to Advanced Steel. So there are multiple possibilities how to use that as well. Speaking of Advanced Steel, okay, let's have a look at what we have done in Advanced Steel 2022 now. It's only part of it. Just give you a brief idea. The first thing that you will notice when you start Advanced Steel 2022 is the change of the application home or the start screen. You have now direct access to the online learning content. The what's new information, well, this is the place where you can find even out more about what I'm showing to you today about the Advanced Steel 2022 release. You have direct access to the online help. You can access directly the Advanced Steel community, including ideas. So I encourage you as a product manager, please submit your ideas and vote. This is something that we definitely use. And you can access our customer support directly as well. All in one place, easy to find. There's also the possibility now to access directly Autodesk Docs. So please keep in mind that you either need a license for Autodesk Docs, but it is also included now in the AEC collection. Simply log in, select your project and folder, and open an AutoCAD file from there. You can select the information that you would like to see, so some kind of filter. You can find the version or file, or even if it is locked by someone, and even who's working on it at the moment. If an advanced steel 3D model is located in Autodesk Docs, you can create ANZ files, bill of material, or even 2D drawings. And the folders will be created in that Autodesk Docs project, and all files will be transferred automatically to it. And it gives you what Autodesk Docs is offering in general, including things like version compare and stuff like that. Keep in mind, this is the first step of collaboration in the cloud. It is great stuff, but please, if you want to try it out, if you would like to know more about it, please reach out to us and let's talk about it. There's more to come. This is just the first step, and more important things about it. There's also a new possibility to publish PDF files to the cloud. This is, however, working only for layouts, not for the 3D models. So how does it work? Just again, just select your layout that you would like to push as a PDF to the cloud. If you are logged into your project, you can select your layouts in Advanced Steel. You can select the target location in Autodesk Docs, and it will create those PDFs and send them straight over. So it is very easy to use, and by the way, it is very fast. Okay, document drawing registration. We have done some modifications here. The best way is to explain it. So how does it work today? Let's say we have a project and we have created 2D drawings, and everything is stored on a drive, and everything is nice and shiny. So let's take the folder which contains the 2D drawings and move them away. So for any reason, that happens in projects from time to time. And if I go now to the document manager, naturally Advanced Steel can't find those 2D drawings, so the status of these 2D drawings is will be switched to unknown. However, if I take that folder and move it back, and if I go to Advanced Steel and open the document manager, all these drawings will be found again, and they will be registered to the project automatically. It's like magic. So it will be much easier to take those files, move them anymore, and move them back. No need to do some kind of additional manual work. One of the most requested items on Idea Station is to be able to select objects for camera detailing. So that is now possible in Advanced Steel 2022. Let's have a look at it. I have here a node where I want to create a camera detail. So I'm starting to do that. And if I go to the properties of this camera, there is now a new tab, which is called Select Objects for Camera. By default, all objects, as it was before, will be selected, but you can also go in there and say Select Objects, and only those objects will be detailed on the 2D drawings. You can mark what has been selected before, you can change the modification, you can add, you can remove stuff. And if you have a look, the bolts of the web email connection of the beam which is going to the back haven't been selected in this case for any reason. So if I have a look at the 2D detail those bolts are not part of it. And again, I can change that, I can update it, I can review. So it's very flexible now to work with that. Another thing is there is this dynamo extension for advanced steel. We have added a lot of new nodes. So in the past, you could create columns, beams, plates, and that was pretty much about it. And now you have access to pretty much everything advanced steel. So that includes like bolts, other objects, welds. You can create complete projects. You can ask for properties of objects. You have modifications like cutouts, drill holes, and so on. So it's there are a lot of more possibilities now in Dynamo for advanced steel, and you can automate your project much better than before. Another request from our customers and idea stations is the following: if you have drill holes in an object and you are stretching the beam, in this case, in the past, those drill holes would move with the modification. Now, by default, they will stay where they are. So it's working only for drill holes. And if you can switch it on and off so that you can work with the old behavior or the new one. There's always something where we improve the quality of the 2D drawings. One of them in this version is the way how we work with labeling. It is possible now to, instead of placing the text on top of the leader line, to place it next to it. You can also define the length of the leader line, and the drawings with the labels will look accordingly. And it is, of course, possible, we have properties of those labels that you can change that to underline again. You can switch it back and forth however you prefer that. Speaking of 2D drawings, we have done a lot in regards to the drawing styles for the APEC area. So if you go to the configuration or localization of advanced steel, we have added new detail styles. We have cleaned them up. We have organized them. It's much easier to understand. The quality of the 2D is much better than before. So creating 2D drawings out of the box will be much better for you now. Another thing, I just want to mention it. It is available since December last year. Shared views is nothing new for advanced steel, but if you have had only the advanced steel standalone license, it was not available for you. Now we have changed that. If you are running advanced steel standalone, you can now use shared views. You can create views of your model in the cloud, including object properties if you like. You can do redlining, you can communicate, you can create PDFs, you can do a lot of stuff there. And that is now part again of advanced steel. It's really worth having a look at it. It's great stuff. Another thing which an enhancement which came from some of our customers was to create DXF files only from one side. So in this case, we have plates with modifications on each side, and it's only visible from either attached parts or in this case countersunk drill holes. And by default, advanced steel will create naturally a DXF file from each side. For any reason, fabricators have requested, I want to have it only from one side. So you can say that now, even if we have modifications on both sides, to do that. And there will be also customers will remark in the DXF output. So if I'm creating now the DXF of those plates, you would see that we are creating them only from one side as wanted, but it also tells you that there would be another side needed. But if you would like to have it like this, here we go. There a lot of additional enhancements as well. For instance, like revision cloud for deleted features. So let's say you have an object and you delete drill holes, and if you go to the 2D drawing, there will be a revision cloud around that area where the drill holes used to be. So marking stuff which is not there anymore. Improved formulas for bill of materials and some other stuff. Have a look at the online help, which you can access directly now, or reaching out to us. There's a lot of great stuff as well. So thanks a lot. That's it from my side, and giving it back.
Awesome. Okay. I just want to say a big thank you to the team for presenting today. I will get the recording published as soon as possible. If you have any more questions, please submit them into the Q&A panel. And as I said, thank you. Hopefully next time we get some more people. If you've got some more interest, spread the word. We will have another session come second half of the year. But for now, thank you very much for attending, and until next time.